Hello viewers, in today's class we are going to learn how to differentiate a function with respect to another function, right? So here we'll solve some problems related to differentiation of a function with respect to another function. So let us start, and let us first take a very simple problem. Suppose we have to differentiate x square with respect to x, right? Now the derivative of x square with respect to x is 2x, right? Because the derivative of x square, right? This is the function and we have to differentiate it with respect to x. So we know that the derivative of x square with respect to x is simply 2x, right? Similarly, if we have to find the derivative of say sine x with respect to x, then we simply write d by dx of sine x, and the derivative of sine x with respect to x is cos x, right? But here suppose we have to find the derivative of x square with respect to say x cube, right? So let us change the problem here. Now in this case we have to differentiate x square with respect to x cube. Here we have calculated the derivative of x square with respect to x. Now here we have this function and we have to differentiate x square with respect to some other function which is x cube. So what we will do here, we'll assume this function as f, right? So f of x is equal to say x square, and let us take x cube as the second function, that is g of x, right? So g of x is equal to x cube. Now the derivative of x square with respect to x cube, it means we have to find the derivative of f with respect to g. It means we have to find df over dg. So what we will do, we'll first find the derivative of f, right? The derivative of f with respect to x. So first we will find df over dx, and then we'll find dg over dx. And if we divide df over dx by dg over dx, then we'll get the required result, right? So df over dx, so the derivative of x square with respect to x is 2x, and the derivative of x cube with respect to x is 3x square. So here we have x, and this x get cancelled. Here we have 1x, so this is 2 over 3x. Now let us take another problem. Here we have to differentiate e raised to sine x with respect to cos x. So what we will do, we'll do the same method here. This is the first function, so we'll take it as f of x. This is the second function, we'll take it as g of x. So f of x is e raised to sine x, and g of x is cos x, right? Now first we will find df over dx. So df over dx is the derivative of e raised to sine x is e raised to sine x, and the derivative of sine x is cos x. And here we have to find dg over dx, right? So dg over dx is minus sine x, because the derivative of cosine x is minus sine x. So now we have to differentiate this function with respect to this function. So it means we have to differentiate f with respect to g. So df over dx is to be it is dg, right? So it means df over dg is to be calculated. So we'll make use of this result. So we have df over dx divided by dg over dx. Df over dx is e raised to sine x multiplied cosine x divided by minus sine x, right? So now cos x over sine x can be written as cot x. So we have minus cot x times e raised to sine x. Now let us take one more problem. Here we have to differentiate log x raised to x with respect to log x. So what we will do, we'll take this as f of x and this as g of x, right? So f of x is log x raised to x and g of x is log x, right? So now we have to find df over dg, right? Now for simplicity, let us write simply f is equal to log x raised to x and g as log of x, right? So now here we have to find df over dx, because we want to find df over dg, and this is equal to df over dx divided by dg over dx, right? So now here we'll make use of the logarithmic differentiation. So let us take log of both sides, right? So log of f is equal to log of log x raised to x, and this can be written as log of f is equal to taking x in front of log x log x, right? So here we have utilized the property log m raised to n is n log m, right? Now differentiating both sides with respect to x, so we have 1 over f df over dx, and here we'll make use of the product rule. So here we have first function, derivative of log x is 1 over log x, and the derivative of log x is 1 over x, right? Plus we have log of log x here, and the derivative of x is 1, right? So here x and x get cancelled, so we have 1 over log x plus log of log x, right? Okay, so now here we have 1 over f df over dx, and df over dx can be written as taking f to this side, we have f times 1 over log x plus log of log x, right? And substituting the value of f as log x raised to x, we can write here log x raised to x, and here we have 1 over log x plus log of log x, right? So the value of df over dx, which is to be substituted here, is given by this expression, right? Now we have to find dg over dx. So here g is equal to log x, so dg over dx, that is the derivative of log x, is simply 1 over x, right? Now we have df over dx, we have dg over dx, and let us substitute here. So df over dg can be written as, here we have log x raised to x multiplied 1 over log x plus log of log x and divided by 1 over x. Now taking this x to the numerator, we have x times log x raised to x 1 over log x plus log of log x, right? So this is the required expression for the derivative of this function with respect to this function. Now this expression can further be written as x times log x raised to taking log x as the LCM here, and then taking log x to the numerator. So we have x minus 1 here, then we have 1 plus log x times log of log x, right? So this is the required expression. Now let us take one more problem. Here we have to differentiate log of 1 plus x square with respect to tan inverse x. So what we will do, let us suppose or assume log 1 plus x square as the function f and tan inverse x as the function g, right? So we can write f is equal to log 1 plus x square and g as tan inverse x. So it means we have to differentiate f with respect to g. It means we have to find df over dg, and df over dg can be written as df over dx divided by dg over dx. So let us differentiate it. So the derivative of f with respect to x is df over dx. The derivative of log x is 1 over x. So here we have log 1 plus x square. So this is 1 over 1 plus x square, and the derivative of 1 plus x square is 2x, right? So this is 2x divided by 1 plus x square, and here we have g is equal to tan inverse x. So dg over dx is equal to the derivative of tan inverse x is 1 over 1 plus x square, right? So here we have the direct result, and now df over dg can be written as df over dx. For df over dx we have 2x over 1 plus x square divided by dg over dx, that is 1 over 1 plus x square. Now this can further be written as 2x over 1 plus x square, taking 1 plus x square to the numerator here. So we have 1 plus x square over 1, right? So here these two terms get cancelled, so we are left with 2x. So the derivative of this function with respect to this function is 2x.